Alright, in the previous video we were looking at setting up the events for moving a drag and drop operation on a div, but the div wasn't tracking very well with the mouse. We've now fixed that where I can click and drag the div, and it's actually tracking quite nicely. I can also go to my performance, put my performance recording on, click and drag, click and drag, click and drag. And when I have a look at this, you can see here that we're running at a full 60 frames a second. So all of these items are under 16 milliseconds. So if these items are all green, you're pretty good. And you can see for all of our click and drag operations, we are running quite well under the 16 millisecond mark, and that's because we're using the transforms and stuff. That's just a side note. So let us go and have a look at how we did that. Alright, so I've reset the page, and the very first thing that we need to understand is local and global coordinates. These are kind of terms that I've made up, but I'm trying to explain that the 0, 0 coordinate differs depending on how you look at the coordinate system. So currently this div has a top left of 0 and has a left of 0 and a top of 0, and the position is absolute. And we looked a while back at fixed. So if I make it fixed 0, 0, it's the top left hand corner of the screen. So immediately here you can see that there's a difference between fixed, and we'll call fixed screen coordinates, right, and absolute, which is local to my container. So when we talk about the screen coordinates, we're talking about the fixed top left hand corner that defines this whole screen space. And when we talk about local, we are talking about 0, 0, meaning the container's actual 0 position. Hope that makes sense. Alright, so there's a function that I want to introduce you to called getBoundingClientRect. It's a function that is on every element, and the function of getBoundingClientRect is that it tells you on screen space what the position of the element is on the screen. So not local, but our global positioning, right? So if I put a breakpoint here and I just quickly refresh the screen and I step over this, you'll see that the offset now says X is 0 but Y is 48. And this makes sense to us because it's screen space coordinates, right? And so this element that I'm working with here is actually the container. So let me just reload this up. We're working here on this container, and this container's top is 48 pixels from the top. So therefore, when I'm defining my coordinate systems on my events, like let's use this mouse down as an example, I'm going to click as close as I can to the corner of this container, and I would expect that if it's local coordinates, that the X and the Y position would be very close to 0. But if I'm working on screen space coordinates, it would be greater than 0. So let me just do my mouse down there quickly. Now, on this event, we have a client X position of 0 because we were quite close to the border, but the client Y position is 53. So why am I showing you this? I'm showing you this so that you understand that the event is using the global or screen coordinate system. It's not giving it to you based on your container, it's giving it to you based on your screen. And this kind of throws your maths around a little bit because I want to move the element based on the local coordinate system. In other words, if I set this rectangle's position to 0, 0, I want it to be at the top left-hand side of the container, but all of the values that I'm getting in is not local to the container. So what do I do now? So at this point of time, you should agree to the fact that when we're looking at it from a local coordinate system, this rectangle is sitting at 0, 0, right? So let's quickly do a mouse down here. We know that the event's coordinates is going to be global, but here I'm also getting the move element client bounding rectangle. So I'm asking where on the screen is this rectangle? Give me the bounds for it. In other words, the left, right, bottom coordinates of this. So we're just going to hop over there and we're just going to hover over here. We can see that says the X is 0 and it is kind of flush with the screen here anyway, so that is correct. And the Y is 48, which it's in local coordinates it's not, but it is 48 in global coordinates. However, our offset of the container's Y is also 48. So if I remove the container's position from my element's position, then I'm resetting the element to be at 0, 0. In other words, I'm forcing it to be local coordinates. So by taking the container's screen coordinates and removing it from the item that I'm trying to move, I'm essentially working in the local coordinates of that container. And that simplifies the math for the rest of the stuff that we want to do. Now next, let's have a look at how do I define the physical movement of the box. Alright, so what we want to do when I'm dealing with my drag and drop is I want to know how far did my mouse travel. So when I click on this thing, I want to move this box from its original position plus the amount that my mouse has moved. And that is what causes the block to stick to the mouse. But in order for us to know this, we need to know a couple of things. We need to know where was the box to start off with, and we get the bounds using our bounding client rect. And the next thing that we need to go and store is where did the mouse start from. And so because this is the mouse down event, we're essentially caching the mouse start position by creating an object literal that contains the client X and the client Y position. And those are still screen space coordinates, right? We can actually skip over the mouse up for now because we're just interested in the mouse move. So step number 1 is how far did the mouse move? Now we get the coordinates of the mouse during the move event in, and so I know what the client X position is. So if I subtract my starting X position from where my mouse is now, I know how far that mouse moved, both for the X and the Y coordinates. So this piece here just tells me how far did the mouse move from the starting position to where you are now. And what we do then is we say, well, take the original starting position of the box and add the distance that the mouse moved. And that will move the box by that amount on the X and the Y position. So we calculate a new X and a new Y position based on where the box was and adding how far the mouse moved. And then we use the translate function on the style to go and set that. So Chrome just died. Let's just quickly reset that again. Thanks, Chrome. Always love it when Chrome dies on you. Let's go and have a look at this div here. So when I click this thing and I drag it, you can see my transform happening. Right? So that would be the new X and the new Y being set there. So let's just quickly do a recap on what we're doing. Step number 1, get the screen coordinates of the container that the item is within. Then, once I actually have the element and I've decided that it is the right element to move, go and get the screen coordinates of that element that you want to move when I put the mouse down. Delete the containers X from that element's X and the containers Y from the element's Y to cause it to almost reset to the local coordinates of that container. So we're taking the screen space part out of the equation. And then, because we want to know how far the mouse traveled, we cache the X and Y coordinates of the mouse on the mouse down. Then on the mouse move, we go and look at what the current position of the mouse is, and we subtract the starting mouse coordinates from that to give us our new X and Y position, which we then use the translate function to actually move the element for us on the screen itself. Needless to say, because we instantiated some memory on a mouse up, we just clean that memory up again. And that is how I perform a simple drag and drop operation in the DOM.